let's start. The content is all about applying STL. Yeah, so no raw for loop or kind of compact and expressive code. And another part is applying modern C++. So basically, it's the modern feature like range-based for loop and all those sort of things that we got from 11, 14, 17, and 20. Yeah, and then the motivation is basically developing an intuition about the standard algorithm. Yeah, and I mean, again, writing compact, beautiful, and expressive code. And I believe this is the practical way of learning the STL algorithms. Yeah, so it is not like, I mean, you learn the algorithm separately, but you do not know where to apply, how to apply. So it's kind of very much solving the problem using the STL algorithms. So I believe this is the practical way. And again, yes, writing no, I mean, no row for loop as Sean Parent mentions in C++ reasoning. Yeah. And compact code, expressive code is equal to less maintenance, less errors, bugs, and less learning curve for your colleague. And last but not the least, interview preparation. So if you are preparing interview, you are going to solve a lot of lead code problems. So yeah, that will help. And before we start, source and credit are from the Connor Huextra, who presented algorithm intuition in CppCon, yeah, in probably 2019. Again, some of the algorithms I mean took for brevity from the Sean Parent's talk C++ seasoning, yeah, about rotate and all those sort of things. And some of the problems are from the lead code. And there is one more person that I would like to give a credit, Jonathan Bocara, sorry, from where I took his image. Yeah, we'll go about it and I will explain. Yeah, so this warning. So I am going to use this macro all, and this X means is container, which expands to begin and end iterator, just to save a little bit space, because in slide I have little bit less real estate available. So, and I'm not going to use std : yeah. So but I would not encourage you to do so. Please don't be smart and do not practice this in your code. I could have used the C++ ranges, but again, I do not want to add one more level of complexity. So I just wanted to keep everything simple. So the first thing is reversing the string. Yeah. So kind of the pattern we follow is I will first give a problem statement, then an expected output, and then what algorithm that we can apply over here. The one way to go about is, for example, before even I reveal what algorithm we can apply here, you can use our chat window if you are knowing it. So what you can do is basically you can just type in quickly that what algorithm can we apply to solve this problem. We will start with basic problem first, yeah, and going along we will improvise and get to the little more complex, not very complex, more complex problem statements. Yeah, so if you know already which algorithm we can use over there, so you can directly comment it on the chat box. And this is not just limited to that you need to use single algorithm, you can use multiple algorithms, but the idea is your code should be compact and expressive. Yeah, so let's begin. So does anyone know by which algorithm we can reverse the string?
Reverse.
Yeah, if you know, just drop down into chat window. It's straightforward. Yes. Okay, so most of the people replied reverse, and the answer is you can create a new string with reverse iterators and add it to the string itself and compare it. Assert. By the way, this is chalk. This is not the way you should go about it. Yeah. So Yes, you are correct. We can use reverse here. And when I mention all with this str, again, this refers to begin and end iterator. So give you one more heads up so that you it do not confuse with the understanding. This way I can save a lot of space in slides, yeah, and code will be also kind of compact. Okay, so next thing is converting string into the lowercase. So you'll be given a string, expected string is in entirely lowercase. Again, what algorithm can we use here? Yes, transform. Yes, too lower is not the algorithm. I mean, it's kind of function expect the character. Yeah, so we can combine transform and too lower. There are lots of overloads to all the algorithm that I'm going to, I mean, demonstrate here. Uh, but I will not going to explain all of them in detail. Yeah, because then it will add complexity, like some introduced in 17, 14, and blah blah blah. Okay, so seems like everyone is liking and things are, I mean, people are quite engaging and chat box is getting full. So let's move to the next thing, addition. So you will be given a numbers which is in binary represented by string, yeah, in container, and you need to, I mean, sum all those things and how do you, I mean, the answer will be in decimal. So for basically all the zero represent zero, yeah, in decimal. 111 means 7, 0111 means 3. So if you sum all of this binary, it comes down to 10 decimal. Yeah. So what we can apply here? Okay. Kishore says accumulate. Okay. No more people. Then yes, right. Accumulate where you say entire range, all the numbers. Yeah. You start with the initial result 0 and accumulate expect the binary predicate. So that means result and string input, and there is this string to integer. This is pretty old, I mean, from C++ 11 or 14, but I mean, you can use from chars, which is introduced in C++ 20, but still, I mean, just to make it simple, string to integer. Yeah. And this is the, I mean, the number system. So it's binary, that's why it's 2. So it will basically convert the string into the integer and you will keep summing it. Yeah. And at the end, you will just return the accumulate result. Okay. Palindrome. So you will be given a string. Yeah. And you need to check whether this string is palindrome or not. By the way, all of the code snippets that I am going to demonstrate over here is compilable. So you mean I am declaring the string like this is still valid? This is string literals. Yeah. And there are lots more, I mean, other literal SV and all those things, but this is compilable code. This is my bottom line, just to make it sure. So what can we use here? We'll wait 5 more seconds. So basically you need to check whether this string is palindrome. And palindrome is like you read from start and end and it is similar. Yeah. It doesn't even, I mean, it doesn't matter from where you read. Yeah, Pratik, Parvati, get it? Get that joke correctly? Yes. Again, this is a joke. This will work. I mean, no doubt. Any other thing? Somebody says use and compare. Yeah. For comparing, we have a dedicated algorithm in standard library. Okay, there is only single algorithm, which is equal. So basically what we do is we will find out start, we will find out middle, which is basically start plus string length by 2. So it's middle. And we give it to equal, saying start, reverse iterator, right? Start comparing till middle, and you are done. Okay, let's move on to next thing. Slide to end. So now complexity is a bit more increased. So basically you will be given a words, yeah, and there are something which is integer but represented in kind of words, and you know from where it starts and where it ends, yeah. And the idea is to slide all these numbers as it is in the same order to the end of string. So resultant output would be look like this, and function would be like slide to end. You provide the container, and when you provide start from index, it's two, like 0, 1 and 2, yeah. I hope, okay, 0, 1, 2, yeah. And from there, next three elements, so 1, 2 and 3, and we can use rotate. And how it works is basically you have array, yeah, and there are three distinct elements within this array marked as red. And the thing is, you need to imagine there are two arrays, and which is what I did, yeah. So one array start from here and here, ends here, and now you can easily rotate the second imaginary array, which is what I did from this start, end, and new start. So this will be a new start. So you can supply this start, new start, and end to the rotate, and it will rotate the array. Nothing fancy, everything is straightforward. Okay, moving on to the next problem statement. Collect in beginning. Again, you will be given a string, I mean words, yeah. And there are some string. Let's say move all of this string marked in black background to beginning, and the predicate is like move all the strings which is less than or equal to length of 5. So resultant, I mean container would look like this. So you'll be given a words into the function slide to beginning, and you will give a length which is 5, like move all these strings which is less than equal to 5 to the beginning, yeah. And again, audience poll, Emil says stable partition. Seems like you already saw my slides before the session, yeah. Any other algorithm that you could think of? It is not just, I mean, limited to that you can solve all of this problem within particular algorithm. You can apply more than one algorithm or any other algorithm, yeah. Okay, so Abhay was right, sorry, Hamil was right, and Abhay is partially, yeah. It's a stable partition, simple as that. You provide entire range, which I again represented by all, yeah, just to save space. And the predicate is simple. You pass the string, you say length less than equal to char count. And how it works is like just partition your array into two different categories. The category X will be on left side, category Y will be on right side. By the way, you can use partition as well, but stable partition will ensure the order of the elements. Yeah. So third curb and wrong, all of the strings will be in same order as it was earlier. This also stands true. Let's say you have given an list of integers and you need to sort by parity. What I mean by sort by parity is, I mean, there are list of integers, you need to partition that thing. Let's say all the even will be on starting, all the odds will be all the odds elements will be in end. So again, it's a kind of partition, yeah. So you can use the partition. Same goes for, let's say somebody asks you to move all the zeros to the end, or move all the elements in container having a specific property to the end. So again, it makes sense to use partition, yeah. But the question would become more interesting when we say, let's say you have given a list of integer which is 0, 1, 2, 3 in random order, which is not sorted, yeah. And you have to segregate all of this, like all the 0 will be here, all the 1 will be there, 2, 3, yeah. So this is the interesting part. And how do we achieve it? Does anyone know? Before that, I'm not knowing this. So if you have any dedicated algorithm, except sort, because sort will sort everything. Yeah. So sort is not something we are looking for, because let's say if I told you, I mean, to put all the threes after all the zeros, then it might not work. So it's segregation problem, not sorting problem. Yeah. Yes, one way to go about is remove if, and then you need to keep changing the container, because you need to copy it somewhere, and you also need to keep track of last iterator. Yeah. Although we can still use the partition, because partition returns the iterator for which start for the next range. So for example, you can see the red and green boxes here. Yeah. So whenever the partition is done, so what it returns is partition point to the next starting range. Yeah. So what you can do is you can use range based for loop and keep reusing that iterator which returned by the partition. And this way you can basically segregate the elements. You still need to, I mean, basically change the predicate. I hope everyone is understanding, because I'm writing code in my mind. But anyways, let's move to the, yes, partition, not recursively, iteratively. Recursively is also fine. Yeah. Because it says, okay, let's move. Yeah, this is quite intuitive thing. Yeah. Concentrate to particular position. So basically, again, given a words, and the question is concentrate all the string starting from T to index 3. So in this array, index 3 is disgrace is 0, temporary is 1, useful is 2, and third is 3. So basically, we need to concentrate all the string around position 3. So Shnehita asks, what is the criterion for highlighted string? So criteria is string should start with T, which is highlighted on left side container. So all the string starting with the T, we need to concentrate all of them at the position 3. Yeah. Somebody says rotate will work, but then how? You need to split array into a lot of things, where, I mean, a lot of sub arrays where you do not know within that sub arrays where the string is. Yeah. So rotate might not work. Yes, we have the answer. Swaminathan says two partition with opposite predicates. Yes. So basically, you need to partition, and do not go into this code. I will explain. Yeah. So how it works is, let's say you have the array. Yeah. And currently all the elements are green. You create a partition where you want to concentrate the all the strings. Yeah. And you say for first imaginary array, yeah, start is here. For second imaginary, end is here, and the new start will be end for first array, and start for the next array. Yeah. And what you do is move all the element to the beginning which does not satisfy this predicate. So predicate is if string should start with the T. Yeah. And this not underscore fn is a standard library function, so you can use it. It just, I mean, reverse the output. I mean, not your predicate. Yeah. So basically, idea is move all the elements which does not satisfy this predicate to the beginning for first array. For second array, we need to do the same. Move all the elements which satisfy the predicate to the beginning. and we have the concentration there. Moving on to top n things. For example, you will be given a language and the number of speakers, popularity basically, yeah, into the container. And what you need is give me a top two language according to number of speakers. So if you observe this container, it's Mandarin and it's English. I mean, which languages has 10 raised to power 7 and 10 raised to power 9. Yeah, so problem statement is there, expected output is there, and what we can use. So somebody says priority queue. Yes, that will work, but it is overkill. Yeah, that will work. Somebody says priority queue of size 2, but then that's the question. How do you find the top two? Max element will work, but it will return only one max element, not two. Let's say, I mean, the problem changes to top three languages or top three elements. I mean, if I talk in general sense, answer is there. Cassis says nth element. Yes, we do have that algorithm in standard library. Yeah, nth element, where you supply the predicate beginning, yeah, and the number of elements that you want. The problem, it is not kind of problem. The way nth element designed is, it will not sort the element. For example, you see Mandarin and English. It could be, I mean, order is not guaranteed. It could be that English could be first and Mandarin could be second. Yeah. Partial should will also work, but which is again overkill. Nth element is, I mean, right choice because you need top two things, top five XYZ things. Yeah. Which is exactly the subtle part of about this algorithm. Okay. Moving on to next step, remove duplicates. You will be given a vector of integers. Yeah. The expectation is give me a unique element, just remove all the duplicates. Samir Joshi says unique, but unique work on consecutive elements only. So if you have consecutive unique element, then only your unique algorithm will work, otherwise will not. Okay. Yeah. Set will work. Yes, but it will work partially. I will come to it. For example, if you use set, yeah, then order will not be guaranteed because set will store all the elements in the sorted order. So again, if you can see my assert statement, it keeps the order in which we encounter the element when we traverse it linearly. Unordered set, yes, I have not tried, might work, but it, as it names applies, it is unordered. So again, the order is not guaranteed. Meenakshi says unique again, unique will not work because it will work on consecutive element. I will come to that algorithm as well. I have the problem for it. Yeah. Okay. So it's copy if, where a bit complicated predicate you need to pass, like just to cache the element. So in capture list, you create unordered set, you create the lambda to be mutable. So you can modify that unordered set as you travel the vector. Yeah. And the second argument, if you see to the copy, if it's begin, so write again to that vector. Yeah. And the lambda says if set dot contain, contains is a method introduced in C++20. Yeah. Otherwise you have to do like find and compare it with the end. Yeah. But contain says if not contain v, then insert into the set and return true. That means return true means copy this. If it is already in set, that means you say return false. And copy if does not remove things, so it will like pass the array, and if the element is not needed, then it will move to the end. So at the end of this copy if algorithm, you will get the end iterator, where it is not kind of actual end, yeah, but yeah, you will get the terminal iterator there, and you need to do end with actual end and erase that thing. So the next statement is v dot erase from first iterator to second iterator. I mean, not first, but this iterator to that iterator. Okay, so the last statement is erase. So basically, when you copy if, it will copy all the elements and return the iterator. When from that iterator onwards, all the redundant elements are there, which is not satisfying the predicate. Yeah. So what you will do is you take that iterator and take the end iterator and discard those elements. You see, this predicate is, if you use another methods, we can still optimize this predicate. This is kind of this thing. So this 4-5 lines you can convert it to the 2 lines. Yeah. So when you insert the element, it will return the pair, which is kind of iterator. Yeah. If inserted, and if it is inserted, then another thing is boolean. So here is inserted is bool value, so which we can return true or false. So this is the optimization again you can do. And by the way, the syntax, this angular bracket, I will come to it in the second part of this presentation. It is structured binding introduced from C++17. Otherwise, you just need to accept the pair and return p dot second. Yeah, pair dot second, I mean to say. Okay, now moving on to the next problem statement. Alphabetical sort. Again, all the languages, this time programming languages. Yeah, and every developer sees which one is popular. So basically, we are not going to find a popularity, but sort it into alphabetical orders. So output would look like assembly, because A is first, A, B, C, and C is C language, C++, C Sharp, Fortran, and at the end Python, which is quite popular. So what we can do? Yeah, sort is obvious thing. Yes, because that's in question. But the actual problem is, I mean, how do you sort it alphabetically? That might work like somebody says integer into set, then you will compare two set. That will work. And Hamil says string compare lexicographically. Yes, it is. We do have the algorithm specifically for this, where you provide two ranges and it will compare it lexicographically.
One small doubt, sorry to interrupt, but I guess you can just use sort normally. Because by default, if we use operator less than of string, by default compares them lexicographically.
Yes, that will work. Yes, you're right.
So we don't need the extra lambda. We can just pass sort all and it will work.
Yes, that is correct. My point is just to demonstrate this algorithm. Yeah. If you want to be double sure. Okay, moving on to the next problem statement. Query for sorted vectors. So you will be given sorted vector, like all the minus element in start and rest the not non-negative elements in the end. Yeah. And all of this is sorted. And the query is like, how many times 5 is repeated? How many negative elements are there? Insert at the appropriate location to maintain the content sorted. This is vector. Yeah. So you have to keep it sorted whenever you are inserting the element, and remove all the elements greater than XYZ, let's say 5. So for first query, what we can do. So somebody says count is yes, but then it's linear complexity. I mentioned one hint, container is sorted already. Swaminathan says lower bound, upper bound. Yes, it is. We can do much better than that. Emil says binary search. Binary search will return Boolean. So our first query is to how many times 5 is repeated. So I mean, obviously you can do binary search, which is what lower bound and upper bound does. Okay, so the answer is equal range, which is combination of lower bound, upper bound, and equal range returns the pair of iterator. The first iterator is the lower bound, next iterator is upper bound. When I say lower bound, upper bound, it's just find lower bound means find the element which is less than equal to 5. So it will stop when it encounters the 5. So that will be our iterator lower bound. Yeah, equal range again internally does this lower bound, upper bound, but why you need two lines when you can do it in single line? Yeah, and the upper bound is basically it will stop when it finds the greater element than specified. So the second iterator will be at 6. Yeah, and at the end distance again given by the standard library. So you say distance between lower bound and upper bound, and it's 3. So 5 is repeated 3 times. Second query, how many negative elements are there? So I mean, there are lots of ways to address this problem, the second query. Yeah, so there could be a lot of correct answer. By the way, my answer is wrong though, so please go to check window for second query. How many negative elements are there? Emil says upper bound. Yes, it is, it will work. It is combination, right? Upper bound and distance. Yes, upper bound with 0. Yes. Any other algorithm you can think of? Upper bound is basically, yes, intuitive way to address this problem. I just wanted to make a point that we can use other algorithm. Not necessarily it is optimized or optimal, I would say. Yeah. Okay. Then it is to find out partition point with predicate, of course, with 0. So my point is applying different algorithms so you can think and develop the intuition when you see the problems. Yeah. Okay. Moving on to the third query, insert at the apt location. You need to maintain the container sorted. Yes, it is upper bound insert. Yes, then magic is revealed. So let's move to the solution. I would say lower bound because insert adds to the next element. So lower bound will stop at 1. Yeah. And then you just insert the position. And the appropriate range would look like assert statement. Remove all the elements less than and equal to 5. So now I think this is straightforward. So it's kind of lower bound. You will get the first position of 5 and then you give it to erase, which I already explained previously. So terminal, yeah, terminal, and n, just remove it. Okay, but let's say when you insert in the vector, it shift all the elements. Yeah, so this is kind of complex, not complex, I would say costly operation. Yeah, and if such type of query you have, then it's obvious to use set. Yeah, and if it is repeated element, you can employ multiset. So basically you do not have to care about keeping the container sorted because set and multiset is associative container. So by default, it will keep the element sorted. And again, we have the same query for first query. We have the equal range within the set and multiset. Yeah, directly use it. No generic algorithm. Even map contained it, multi-map. And Same upper bound, as I mentioned, it stop at the greater element. Yeah, so you specify 0, it will stop at 1. And you say distance, so you will get the negative elements. And for the insert, it's just one line, because your container by default insert at the sorted position to keep the container sorted. Yeah. And for removing, lower bound, which is less than equal to, and you say 5 less than equal to, which means it will stop at first 5 and erase all the element after the 5. So query is something like you need to associate your element in certain order, then use multiset. I will, okay, so by default, the comparator is less than, yeah, and you have particular object or classes that you want to keep in certain fashion, then you can pass the predicate, yeah, comparator right at the time of declaration. I will do it in one algorithm. And here it is, frequency sort. So I usually ask this question when I am interviewing, yeah, to the candidate. So you will be given a list of integers which is repeated. You see 2 is repeated many times, 5 is repeated, 1 is somewhat not repeated, yeah, 3 is repeated, 7 is repeated, yeah. And the expected output is sort all the numbers based on frequency of occurrence. So let's say 5 is most repeated element, yeah. So all the 5s come first. 2 is the second least repeated element, so all the 2 comes afterwards, and list goes on till at the end. For example, in this case 1 is not repeated, so it comes at the end. So basically we are sorting the container based upon frequency of occurrence. There is no dedicated algorithm, by the way, so it's a combination of things how you do it. So I have the one way of it, I mean doing it, yeah, and you can propose the another one. So somebody says priority queue. Again, the priority queue is when you continuously need element which is less, yeah. So multiset equal range is lookup algorithm. Swaminathan says map, you count the frequency. Yes, it is, that's half part of problem. Yes, so Swaminathan sorted it, I mean solved it partially. Amandeep says brute force, hash and count. Again, yes, that's same approach as Swaminathan mentioned. Frequency count. Yeah, I will do it, frequency counts. But how you can do more? I mean, you do frequency count, then you have the map. Okay, let's move to the first thing. Okay, I have counted the frequency. Now you have 7 repeated 2 times, 4 repeated 4 times, 3 3 times, 1 1 time, 5 repeated 6 times, 2 repeated 5 times. You have the list of pair. You cannot sort map or unordered map because those are, as name suggests, unordered or associative. Yeah, so they're iterated accounts, so you cannot say directly sort this map. So now you have another problem. You have pair to sort it based upon frequency. So Manish says maintain the count in hash set, which I already did. Now what is the next step? Okay, so we reached here. What is the next step? I want compact code, by the way. Yeah, I mean, you can keep find it in unordered map, and then again you have to rewrite in same vector. Yeah, that is another problem. So I will come to it, that how you rewrite into that map. I would say container, given container, which is v, vector v. Yeah. So okay, so next thing is to sort is create a set, add the comparator. Now your pair is completely sorted based upon frequency. So 5 is most repeated element, which is 6 times, so it's first. 2 is 5 times repeated, so it is second. Okay, now we have the list, I mean pair of list, yeah, which is sorted. How do we rewrite into the container given? As many number of time it is. So basically we have the 5 which is repeated 6 times, which is in pair. You need to rewrite into same container. There is algorithm fill n. Yeah. So you say for each entire set, which is kind of list of pair. Again, the predicate, mutable predicate. Yeah. And you say first iterator to start writing is previous, which points to begin of, vector given. Yeah. And the first pair comes in, and you say p dot second, which is this many time write, and p dot first is what you need to write. Yeah. And I'm fill underscore n will write it as many times it is given. Yeah. And when it completes the write, it will return the next iterator from where we can start writing again. So it is something like this. So first 5 element is written. We have next time previous. We'll feed it to the fill n, and we'll keep going until we exhaust the set. And at the end, you have the frequency sorted container. Okay, let's move to the next problem. Somebody pointed out earlier that we can use unique. So here it is, the application. Yeah, you will be given a list of, let's say, integers in string format, and somehow were multiple writers. So somebody added, randomly space in between. And what you need is number, space, number, space, number, space. So here you can employ the unique, which accept the binary predicate, and you can say left and right both is, let's say, space. Then just move it to the end. So again, erase remove idiom, it will move it to the end, but does not remove it, or does not erase it. So you will get the terminal iterator at the end of unique, and you just erase it, and at the end you will get number space, number space, number space. But keep remember that unique will only work on consecutive elements. Count equal adjacent characters. So basically you have this string, there are some characters repeated, for example, and this is the first time a is repeated, a, right? Second time a is repeated, c is repeated, b is repeated. So there are a total of 4 repeated elements, and you have to find it out. Again, chat is open for your answers. Unique does not return anything, it returns iterator. But yeah, you can pass the capture, any variable which is global in capture list of lambda, that is predicate, and you can do it. But this is not good way. Yeah, you can use unique, but this is not the good way. Count if with mutable. Count if will accept only one range. Kashish says adjacent find. Let's see. Adjacent find will work. Yeah. Inner product is something we can use. So it's, let's say, you pass one range, which is given string, start from actual thing, and the next range we do not have. So what we can do, start with the b. So it's begin and next is second argument of inner. Yeah. And you say initially the result is 0, and you say the overall operation is plus, and the adjacent operation is equal to the compare if both this thing is equal to or not. So you can visualize like this. This is from Jonathan Bokara's talk, 105 HTL algorithm in an hour. Yeah. So this is how inner product work. So basically you will have 2 ranges, and it does the element by element multiplication, and at the end, if all this satisfies, then addition at the end. And you can customize this operation by last 2 arguments, which we already did. Multiply is somewhat we replaced with equal to, and plus is by default. Okay, moving on to the next question. This is, question is complicated, but the solution is very simple. Yeah. So for example, you will be given 2D plane and you will be given points. Let's say there are 2 points, 1 3 minus 2 2, and if you plot that point into 2D plane, so this is 2 and minus 2, and this is 1 and 3. Yeah. And the question is, you need to find closest point to the origin. So as you can see, this is quite obvious that 2 and minus 2 is the nearest point, and we are asked to give only one nearest point. Yeah. So the answer is obvious, 2 minus 2. Now let's say there will be given 3 points, and if we plot it, I mean, okay, I missed this Euclidean distance. So basically how you find out the distance between one point and another point is by using this Euclidean distance, and the another point in our case is 0 0 because it is origin. So the formula is right there. Yeah, it is not complicated. That, I mean, x minus x1 square plus y minus y1 square and all square root. So the first given point is 3 and 3, which is here located by purple color. The another point is 5 minus 1. Yeah. Third point is minus 2 4. This seems like there are obvious things. When you plot the point on the Cartesian plane, then it is quite obvious that which is quite nearer and kind of thing. Yeah. But you will be given a list of point, and you need to find out k closest point to origin. So answer will be obviously 3 and 3 is the nearest first one. Minus 2 and 4 is again the thing you need. And Hamil, get it? Nth element? Yes, it is. And that was obviously first question, so you can, I mean, get to know it. But I have another solution. Yeah. So just think about it, because we already addressed that algorithm. Kishore Devnath said priority queue. Yes, that will work. Sort by Euclidean distance and pop k element. Yes, it will. So it is kind of, you declare the priority queue, and at the time of declaration, you pass the iterators of vectors with the comparator at the priority queue. Yeah, that will be one line. Yes, nice solution.
Can you repeat the previous solution, please?
Previous solution.
It's in the chat, I guess. You meant the priority queue one is in the chat.
So Kishore Devnath suggested, and I mean, as far as I can think, it's one liner. Yes, two liner. Sorry, you need predicate. Yeah. Okay. Obvious answer is partial sort with copy. So at least I can use that another container in SR to compare it. And this is Euclidean distance. The second point in distance function is 0 0 because it is origin, and the predicate is quite simple. You just comparing 2 points with distance, and this star 1.0 is just for the converting into the floating value. The main thing here to focus is algorithm. If you see from the problem perspective, it looks complex, but it's just one algorithm. Yeah, and you are done. So yeah, again, I mean, n element is somewhat you can apply, which is quite optimal here because you do not need to sort. Okay, let's move to the next thing. Distance between closest and farthest points. So again, 3.33, 5.1, minus 2, and 4. There are 3 points given, Euclidean distance. Yeah. And what you have to need to do is you have to find the nearest point, sorry, closest point to origin first, and the farthest point to from the origin, yeah, and you need to create, I mean, find this distance, the red line. And Hamil says min max. Yes, it is. Comparison not valid because it's floating point, yeah, but the algorithm is min max. So it's just kind of list of point. You find min max, but the predicate is something again Euclidean distance, which was again the same as copied to previous slide. So again, making that point, everything is there in standard library. Yeah, it's just that you need to develop intuition, and you keep applying the algorithm whenever you encounter any problem. Then it will develop automatically all the time. And what I did usually, which helps me, is when I need to write a for loop, I just take a pause and go to CPP reference. And within 5 minutes, I don't find anything, then I will write the for loop. Next question. Search in sorted, rotated, sorted array. Yeah, tongue twister. So this is the array. For example, it was like something earlier 0, 1, 2, 3, 4, 5, 6. Sorry, there is no 3. Yeah, but it is sorted. And somebody rotated it 3 times. And this signifies it is rotated 3 times. The expectation is you need to find an element and return it is exist or not. Yes, the problem is from lead code, by the way. Maybe Son also included it. Yes, it is. How can we solve it? If you know it, just take a while. I mean, let other answer, and if no one, then you can. So you have to find the element in sorted rotated array. The hint is there is two different array here, imaginary. Yeah, if you do not remember Hamil, there is two array. That's a hint. Money says find pivot point. Yes, that is also under the name of partition point.
Hi Vishal, I didn't get the question. So we have to find 7 in the second array or the first array?
So okay, technically there is a one array which is sorted and rotated.
Yeah.
And you will be given any number. For example, here it is given 7, and you have to find it whether this exists or not. The ideal way is you go one by one element, which is linear search, and you will get it.
Yeah.
You want to find bit better solution than it.
Okay. So the STD find would be right answer or not?
I mean, it will do the job. Yeah.
Yeah.
But again, as I mentioned, it is linear search, which I mentioned.
Okay.
So
Okay.
one by one element.
Okay.
Manish Srivastava says find the pivot point. Yes, it is, but which algorithm it is to find the pivot point? Aditya says binary search on pivot. Yes, but then again, STL algorithm. The answer is correct. You find pivot point. There is two array. If you have some, let's say, one element is greater than then you search in first array or in second array. Partition does the partition. It does not find the partition point. You can find the partition point, and there is a partition point, by the way, algorithm, which gives you a partition point, but you can also use sorted until. So it find the point, it is sorted until, yeah, you have the terminal point, and you just compare the given element. If it is greater than the start element, then it is in first half or in second half. Based upon you do the binary search, and the binary search is again standard library algorithm, which return true or false.
There's a small mistake in the slide. The sorted rotated search should return a boolean.
Yes, that could be. Yes. In that case, you can use partition point, which is in comment. Nice input, by the way.
Because you are asserting that it is true and the return type is int. So either case, and binary search returns a boolean. So it
Yes.
should be a boolean.
Yes. Okay, moving on to the next question. This is from corner who extra. I reveal the solution because my animation is not correct. Okay, so basically question is you will be given one string which is alphanumeric and you have to find only alphabetical characters and reverse it. Yeah, so it will look like D and CD was in last. So the first it is repeated 1 after D, C. After numeric will be as it is there, yeah, on same position. And the next is AB, so it is BA. So at least half part is already there. So it's just to guess the next half part. This is lead code question and the solution is demonstrated by corner who extra. And he used the only single algorithm partition, which is not intuitive. So I have not used, not intuitive, I would say expressive, not intuitive. Yeah. So basically what we are doing in this current solution is we are passing the entire range and we copying if the character is only alpha, that is alphabetical. Yeah. So our string R will contain ABCD at the end of copy if. Abhay says transform back inserter and alpha. Yes, it is, but it is not back inserter, it is reverse begin iterator. So transform say first range, write it to the second range. So we say starting from begin S, yeah. And then we have predicate. Again, it is mutable predicate because we are creating I, which is not a good name, by the way, yeah. And assigning it with the reverse iterator. So basically we are starting with D at the end. And if we encounter the alphanumeric character, sorry, alphabetical character, then we'll overwrite. If it is numeric character, then as it is. Okay, so Ankur says replace copy if. I'm not sure, it might work, but then you need to know the end character, which is A, B, C, D. So at least one time you need to parse all the string and have to gather all the things. Basically, alphabetical characters. Or you can do for loop, begin iterator, end iterator, which is not kind of very good way because then your colleague has to sit 5-10 minutes to understand what you are doing. Okay, moving to the set algorithms. So you will be given two vector list of integers, yeah, and basically it's in random order, but ideally if you see in comment it is 1 2 3 4 5 and another is 4 5 6 7 8, and you have one query where you need to find a common elements. So there is two vector which are the common element, which is in this case 4 and 5. The another query it's non-common element, so exclude the 4 and 5, give me everything else. Another is if you combine everything, what are the unique elements and what is the difference if we minus one set from the another. This is less used algorithm, but helpful if you have two ranges and you need to compare it, not just compare in the sense equal or anything, but you need a data when you compare it. Abhay says, okay, first for intersect, Sun, yes, all these are set algorithm. So the first solution is set intersection, but for this to work, our vectors are in random order. So first we need to sort it. So I have sorted vector 1 and vector 2, assigned it to the S1, S2, and now we can apply these algorithms. Because the limitation of this algorithm is work on only sorted ranges. And same for non-common element, set symmetric difference. Pass two ranges, inserter where you need output, and it will give a non-common elements. And the unique element is just set union. and the set difference. So these are the algorithm quite useful if you are comparing two ranges, but make sure those ranges are in sorted order. I have given the images right hand side so that you can understand what this algorithm is doing. Okay, then let's move to the next thing, which is that all you got? Yes, it is for STL, but we can still write compact and expressive code with the modern C++ features. Yeah. So let's dive into 2-3 things. I'm not going to cover each and everything provided by modern thing. Yeah. But most and quite useful that at least I employ in day-to-day coding whenever the standard which we are using it internally in company permits. So the first thing from the modernness is user-defined literals. So earlier, let's say you need to represent anything in units, measurements, right? KB, MB, kilo, or ton, or let's say binary, octal. So there are measurement unit. So we used to define a macro. Yeah. And when we assign it to any other variable, it's kind of you need to use the macro. So output will still be in a base unit, which ideally it should be. Yeah. But you can do bit better using string literals. So string literal, how it is work is like there is this your data type and your literals afterwards. And to make this work, you need to do like this. This is the user defined string literals underscore KB underscore MB, and whatever prior to the literals will be the argument. And again, I use const expert, so it is work like macro. There is no runtime performance penalty. So whenever you are encountering any measurement unit, you should use string literals. Sorry, user defined literals, not string literals. Yeah. Moving on to digit separator. Very simple thing. I see a lot of developer writing this, and I need to sit and count 0. And I would suggest do this instead. Yeah. So I do not have to count zeros or repeated elements. This is just syntactic sugar for developers. Compiler just ignore that tilt thing. Yeah. So, and this stands for, I mean, pretty much everything. And you can apply it anywhere you like. It is not like after 3.0 or 4.0, but just so that your colleague do not curse you. Yes, and this is from 14. So this structure binding. So let's quickly go. So there are this list of integers. You need to find min-max, and min-max work like it will return a pair of iterators, and you need to declare. You can use auto here. Yeah, there is no problem. But again, that auto is kind of deduced by pair, right? And you need to do like this before assert work. And what you can do is instead is like use structured binding, this angular bracket. Yeah. And this feature taken from C# and JavaScript. Yeah. Where they call it destructuring. In C++, we call it structured binding. And same you can use to iterate the map here, like we counted the frequency right earlier. So in for loop, you can do the structured binding. Okay. So nothing special. Again, fold expression. So it's kind of ellipsis we used to use, like 3 dots, which accept the arbitrary number of arguments. So you can use, for example, the one use case could be a print that can print anything and arbitrary number of argument that you given, irrespective of type, because we templatize the parameter pack. Yeah. And I will not go into much detail respecting the time, but there are lots of information available on internet. So it's just that fold expression will fold the thing I mean, until all the argument is carried out. Yeah. So for concat, you can use to concat the strings and numbers and whatever it is. Yeah. And the another use case could be like if you need to push back 8 to 10 elements, which is less likely the case, but let's say it is. Yeah. So you can do like push all and arbitrary argument using the parameter fold expression. Yeah, sorry, parameter pack. Yeah, that 3 ellipsis dot. Ellipsis is we used to call it in C language, but in C++ it's parameter pack. So there are template parameter packs and these things, and again, yeah, push all will push all the elements. It's just unfold your pushback. But when you are doing this, it bloat your code because it is template. So that's a drawback. Finding array size. So in earlier C code, I saw this, yeah, lot of time. Size of complete container and then one element, and you divide and you get the array size. In this case, in pointer case, this will work and give you a false answer. So with C++, you can use type deduction and you can deduce the array size completely and return it, and which is again const expert, so no performance penalty. And again, nothing special there. It's just a good practice. Yes, one more thing. Hamil says std use array. Yes, it is. Yeah, sure. Ideally, we should. And then higher order function, returning function. For example, there is program counter and arithmetic logical unit, which store some hexadecimal, dead bab, and badash. Yeah. And there is some ROM address width. Yeah. And there is ALU width. Let's say it's 16-bit and 8-bit, and you need to limit your program counter ALU within certain bit. So if you mask, most upper bits, then it will be only a bab. Yeah, here in first assert statement, and for next assert statement it is 0x55 for 8-bit. Yeah, and ideally you like write function which accept data and length, and you do some masking like and reversing and blah blah blah. Yeah, this is a general way. You can do much better by eliminating the second argument, that is ROM address with ALU width. If you use lambda, this is one more use case of lambda. Yeah, it is not just that we use lambda for predicate. So what you can do is lambda returning lambda. First argument is length, which is be the capture to the next lambda, and next lambda accept the data, and you are performing the same operation as you were performing in earlier thing. And you declare another lambda by saying the bit length up to RAM address with ALU, and now you have 2 lambda more up to RAM address and up to ALU address, and you can use like this. At least to me, this is expressive code. I follow this thing. Yeah, it complicates if you do not understand the lambda, how it works, and how higher order lambda returning lambda works. But it is not that much complex if you know how lambda works, of course. Yeah. So you just eliminated second argument, and now you can it is much more expressive. Up to ROM address, program counter, up to ALU address, ALU. Okay, other lambda use case. Let's say you need to perform some initialization step 0, 1, 2, 3, and there are some error message, and if you in any of steps fails, you return the false. It's kind of the pattern is there are certain function you call, and other pattern is repeating thing. Yeah, returning false, and pending message. What you can do instead is you can create a lambda within that function right away. Yeah, and pass the message and function, and for rest of the steps you pass the message and function as argument, which returns. So this is much more scalable and less line and expressive code. So these are to another lambda use case, yeah, to make your code much more precise and compact. And with that, last thing is, I think, scope bound objects. It's like frequency of map. Let's say these are frequency. How you used to find earlier is like find, which return the iterator. You compare it. If it is not equal to n, then you say, yeah, it is there. But in this case, there is a problem that even after the else, the iterator exists. Yeah. The other thing is you can do is like declare that thing within the if. Yeah. So these are the scope bound objects, and you can do same thing in switch case. And this comes, I mean, this feature comes from C++17, of course. And then this for loop, range-based for loop, again added this feature. I don't know why they forget even in this for loop. Yeah, from C++20. So you declare wherever you need it. And again, 2 to 5 second pause. There is nothing special. It's just declaring variable within the if, switch, and for. And questions? Yeah, I'm done.
Thank you so much, Vishal. Does anyone have any questions? I know we are out of time, but if we have some quick questions.
Okay, what ways, somebody has questioned, some posted Vivek Sharma, what ways can use to compare complexity of alternate solution? So my point was to, I mean, you can write much better code or much more precise code with the STL. But yeah, there are for loop. If you think that if you combining two algorithm and it is not something giving you a performance thing, then of course you can write the raw for loop. But ideally you should pause a while when you use to for loop.